I always have to put it on my phone so I can make sure it works.
So wait for the echo.
Yeah, I wait for the echo and then I'm like, okay. Because I'm on my laptop again, so I'm not, at home. Right. Okay. I think we are here because I see it, but I don't know. Maybe I'll let it sit for a minute to see if anybody's out there that's
Yeah,
joining
I'm
us.
gonna advertise at least again in the Ohio group that I posted in.
Yeah, do it.
Oh, I'm already getting tagged in meteorologist posts.
Oh, good. Good, good. So anyway, let's see. Let's see who pops on. I always like wait to see if anybody joins in the chat. But it's a tough act to follow, because Tamitha just did hers and now we're doing ours.
That's okay. I mean, the thing on reinforcing what she went over as well.
Pretty much. I mean, because she had a lot of good information. So we're just
The backup team.
the backup team, the B team. That's the B
A
team.
B team. I like that too.
Yeah. We are the B team to follow the A team. All right, looks like we have a couple people here, so that's good. That's good. Yeah, so we decided to do this live. Going
I
over.
love the hype title.
Yeah, you like that? Breaking news. Oh my God. It's the most epic thing.
Legendary, never before seen.
It's the most epic thing that's gonna happen ever
You'll never
tomorrow.
see this again, even though we've had it 3 times now.
So anyway, you just gotta do it. You gotta play the game. But yeah,
I
so
am gonna call it out regardless.
for those that are just joining, oh yeah, we haven't started anything yet because I like to let it run for a little bit. Um, but we're going to go over a quite eventful last 24 hours, to say the least, with a very angry sunspot. Um, we have a special guest with us today, Liz Butler, who's a actual forecaster, to add in some commentary here as we go through what has happened. So we're happy to have her here. I know we had her on, as a solo stream a couple weeks ago. But didn't realize we were gonna have her back so quickly. This is how, like, it's fun when the sun actually gives us something to talk about.
We
So
still need to get Sarah for one of these events too.
yeah,
She's like, maybe we can join in one event that actually happens, and then silence.
I know it's like it does
And I
nothing.
think she's back to work now.
So
Yeah, she is.
it's all good. But anyway, so we're gonna start with going over what happened. So we'll like Christian's our, master of the J Helio viewer, so I'll hand it over to him to go over all that fun stuff. And then we'll get into the forecasting and what we're kind of expecting. Long story short is the G4 watches have been posted, so we should see something out of this. So anyway, without further ado, I will hand it over to.
We can probably start with just current events too, because we
Yeah,
had
yeah, yeah, we could.
more of oh, come on. We had some
Yeah,
Want to start the
interesting
slide then?
stuff.
yeah, that's
Yeah, I
right.
can
Yeah,
share the
we have a slide
slides.
out. We'll go over.
I
It's funny when these
Cool
things
images
happen,
coming.
like things happen, and then
Yes,
you're
they
like,
are coming.
oh, coronal hole, what was that? That was like so 3 days ago.
Oh, come on. It's still going,
It,
so that's
yeah, it
not
actually is.
entirely
It's
correct.
still going. It's not over yet.
So let's
Absolutely right. So yeah,
where
bring it
are
up. So
we?
yeah, we're still in a Corona hole stream.
I think
Can't,
that's right.
can't forget
Yeah.
that.
So I think that's the right one. So
Yay.
yay. Okay. So we're gonna start with where we at right now. And right now on disk, we have a couple of interesting players. We have kernel hole 52, which is negative polarity. It still works for us. I mean, it
Mhm.
was fairly
We're like
geo-effective.
750 right now, I think.
Yeah,
Uh yeah,
over
we're still
700.
clocking at 700. And there is kernel hole 54, also negative polarity. It's a little higher latitude, so well, something's gonna come, but we have two active regions and they are definitely not happy with their current state, I would say,
About time.
of magnetic field. But we did manage to get another Hilke event, so we crossed 1,000 nanotesla a few times. Here. That all came from that little coronal hole, which actually is not little. It looks like a crack in the sun, except it's not.
Mhm.
It's fast wind, and it definitely created some very interesting and very sporadic aurora. And it's still going because we are dealing with another substorm right now. So if that continues until CME comes, we are looking for some very interesting chain of events, but we shall see. But yep, another kind of long duration. So kind of glow on the horizon for mid-latitudes with periodic flare-ups. I think one of those substorms was actually caught in Northern California. So those coronal holes can do some impressive stuff.
That's
But
okay.
that's where we at right now. We got a very active and very unhappy active region, and Christian's going to talk more about that. So definitely have some X flare probability, some risk, and proton events. But I mean, we have a proton event going on right now. So
Well,
definitely, I would say that the risk of proton event is about 100%.
I mean, it's definitely getting worse as it goes towards the western limb too. So for those that haven't seen it yet, here's the 131 animation, the super hot plasma. I wish I would have gotten a little before that, but you see the big event here with the M8 and that kind of I want to say destroyed the sun just to be really dramatic for fun since we're hyping this up.
Story.
This is a pretty fast 24 hours too. So you can see two big events here, mostly the big one beforehand, and then there was a littler one after that, which do we have any analysis on that CME yet? I don't remember if it's been long enough time that we have a model out for it yet or not. That mini one right here, that would have been what, 1600? Yeah, we should have something, right?
I
I
think
want to
it's
say.
in the Huxt model. I think
Okay.
it, yeah.
I haven't looked too much into that Hux modeling yet, but the point is, so nice Earth striking zone, and then especially the bigger one. Let's combine it with 304 so we can actually see some chromospheric detail here. But it really just, as Tamitha called it earlier this afternoon, basically left a giant scar in the sun as the filament tore through all this northern area and all through down here. It was a very pretty eruption, and you've got all these nice P's coming through. We had a filament eruption down here just before then, another launch from this group, which likely has some sort of Earth-directed CME, all coming from this one angry sunspot 4100, which just to look a little bit on it, I've got it on track just to see the evolution of it over the last 24 hours. It's not terribly big, at least as far as sunspot groups that I have seen in my days. Let's put this actually here. That way it's a little smoother. There we go. But it does have some nice shear, especially on the northwestern area. We've got a negative penumbra that looks like it was basically being pushed up against the positive end. This was causing a lot of the activity earlier. Since then, it's separated quite a bit. In fact, I'd be willing to bet that this side either becomes its own sunspot later on, a little bit further on from it, or just disappears entirely. So we'll leave it at the very end of it. What we do want to look forward though, because this is not done, we've got in the northeast a pretty good region. It's still a little small. I believe it's technically a delta. Yeah, it's a little far apart in distance, but I'm sure it's probably technically a delta at this point. And then the south edge as well. We've got a lot of different shearing going on. Not quite a delta region down here from the looks of it anymore, but there's plenty of potential because we've got this entire area being a negative penumbra as well, and it looks like it was growing into it. So this region's not done. It's probably going to erupt quite a few more times. And then just for fun, let's jump out all the way and see the CMEs from Glasgow, where I like actually doing the differential models because that's just easier to see, at least in my opinion. So big one there. Actually, let's slow that down. I forgot how many frames Glasgow goes through. It's not that many. So big CME, little asymmetrical, but clearly full halo. As to what it's from, it's a little lumpy here and here, and it looked like the main blast from the sunspot was mostly to the northeast. I'm thinking the filament then that erupted at around the same time added to make it the full halo. I know that's still kind of an open discussion, and it'd be fun to see what actually ends up happening. Mostly, though, if we just assume for fun the flux rope that the initial eruption had at the beginning isn't influenced by anything else, we have a mostly bipolar flux rope, so mostly parts north and south. Northern likely to be the first one, and it likely to be the little bit stronger one, assuming everything stays consistent, which isn't going to happen. Just on that note,
Yeah,
not with the
yeah,
influences we have.
this is a bit on the complex side, so I think even
Yeah,
Tam
I wouldn't really count on any sort of analysis being able to figure out exactly ahead of time. Will be interesting to see the configuration if there
Yeah.
is any.
Yeah, I
And
think Amazon was
then
saying that we might not even be able to tell where the
yeah, so
tropes are.
something like an October
Yeah.
situation where it just ends up being one blob of a mess. It looks like Glasgow ends about 2000, so there's not really any signs of the other CME at all. So I'm still pretty clueless on that one. And then I want to say, actually, that was pretty much it. I was going to show some pretty post-eruption arcade loops and, go through 171, but I haven't been able to get access to that in Helio viewers. So sorry, everybody. No pretty loops, at least in that wavelength.
It's all
Go
good.
ahead and drop it back to the next person who wants to go on from there.
So shall we get into all the forecasting then?
I think so.
Sure.
I'm sure that's what everybody's been waiting for. So
Yeah, I'm pretty sure too. So we have, oh, okay. I don't know if I have everything pulled, but we can start with M2M.
sounds good.
Yep, a lot of people were holding their breath for NASA modeling. So thank you, NASA, for being on top of things. We do appreciate it because their model is often out first. They do model for quite a few missions in the sort of inner and outer heliosphere. So it is super important for them to get the forecast out as soon as possible. And we benefit because we at least get some idea what might happen. And they got the model posted as usual. The shock came out first. And I think that got cross-posted in several social media accounts. And that was interesting to watch because arrival was predicted very early. This is bulk modeling or the leading edge. So this is actually the material of the CME that's going to arrive, not the particles that will be accelerated by it, which we're seeing now. It's all the protons that got picked up by the flare and got flung all the way to us. So arrival is anticipated around midday, June 1st UTC. So that means it's potential early morning arrival for us. But again, the error in the model itself is about 7 hours on either side. In practical application, it turns into more like 10 to 12 hours.
One quick thing I want to say,
Yeah.
because I just talked to MTIM about a month ago, is the plus or minus 7 hours is not from the model, it's just their convention. If they don't have
Oh.
better uncertainties, they
Oh,
just slap on plus or minus 7 hours.
Oh, that's really
Oh.
cool. So it's just the sort of safety range.
Yeah, it's
gonna be
roughly
about
somewhere
7.
between a third and a quarter of a day, give or
Okay.
take-ish.
Yeah, it's in studies it comes out as 10 to 12 hours, so that's probably 7 hours is sort of just
Interesting.
it's just a number. There was I think recent study, when did it come out? 2024 actually, that looked at several models and
Ooh.
obviously performance in well-established models was better in some that are posting it very periodically for big events. But Met Office, M2M, and SWIPSy actually came out as sort of most accurate on the average, but the margin of error was 10 to 12 hours. So it's about 24 hours basically.
Yeah, so
Give or
basically,
take.
basically where it's like we can get it within half a day if we're really lucky. The other thing that I want to say on this slide is that the 1324 is stupidly precise. So like I haven't actually seen M2M's like interface, so I don't know if they have that minute precision. But SWIPSy, we only get hour intervals in our SWIPSy in our Enlil runs. So I don't know where they're getting the 24. That's
So
awfully
24,
specific.
that's a
it
good
is
question. I
very
wonder if they do it in the
specific.
ensembles.
No, this was not ensemble run. So
I mean, I think literally the model
Hmm.
just shows hour by hour too, doesn't it?
But
no, that's what they post in Donkey. So this is how it comes out. Do we want to take a look as far as the live model and what it looks like?
Yeah, I'm curious
Let's
personally. We
do
got some
it.
time. I like this
Great.
to be more of a discussion one since it's a bigger event.
Yeah.
Discuss away.
Let me pull it up.
Yeah, they do get down to the minute. Well,
They do. That's kind of their standard.
I wonder if that's more of a because they're research based, right? So
Well,
they
they're
try
still
different things.
operations. It's
Yeah.
still operational. So we have a question for Karina.
Yes, we do. It's like,
All right.
how are you so precise?
All right, so I think I found it. Let me share a different screen. Let me just post it to a different screen. Yay, there we go. Yay.
Hey,
So
works.
that's what we're getting. This one actually has 3 CMEs, believe it or not.
So that
There
has
are two CMEs that came off that were forecasted as a glancing blow. And all of that got swept into one. It's not an ensemble run, it's just a run of 3 CMEs. And this is again just a model of how it's going to play out based on density and velocity, but it's not how things will play out based on CME interactions.
Right.
Usually they get compressed. There is some interaction potentially of the magnetic field, and Liz can correct me if I'm wrong on this one. CMEs do not cannibalize each other. They interact. They compress each other, but they do not eat each other up. It's going to take quite an incredible and unfortunate play of the events for CMEs to cannibalize each other, because that means their magnetic fields are exact opposite, and they're really just it's tail of one CME and head of another CME. And
That's a
that's how
fun thought
you get
experiment, though. How much energy and what would it look like if you have two exactly opposite opposing strength CMEs with opposing magnetic fields, one catching up to the other, interact, and what would it look like in data?
I was gonna say that's also a problem in cosmology and galaxy merging. They also use the
Oh,
term
galactic
cannibalize.
magnetic fields?
Yeah, and they're also trying very hard as a field to move away from such violent terminology,
Yeah.
and trying to use different words. So, but yeah, that's actually a very, very good point.
we
Yeah,
are
it's
going with
like you're
CME
merging balls of
interactions.
yarn that a kitten tangled than anything else.
Yeah,
Yeah, we're just going with CME interaction. Sometimes I mean, there are interesting things that do get published about CME interactions where the initial shock of the CME actually goes through the flux loop, so kind of heats it up and compresses it a little bit. So you see some of it in data if you look hard enough. If you incline to look hard enough, because you're probably going to be shooting Aurora, hopefully, if you have several CMEs in the row and the magnetic field is favorable. But if you're chasing data, then yes, it's going to be fun to look at. So that was M2M modeling. The speed used in modeling was pretty high, so 1300. Problem with this, I have to pull the model, but it's slightly underestimated ambient speed. So we're running about 150 to 200 K faster, kilometers per second faster compared to what went into the model. And I do have another slides on the how it plays into that forecasting error. Who was next?
Yeah, what's our next?
Yeah, UK. So they do ensemble modeling, and that's their standard. M2M wants to get the model out faster, so sometimes they do run ensemble, but it's it's pretty much all day endeavor. So for fast CMEs, they probably don't have enough time. By the time they complete ensemble modeling, CME is going to be here. It just takes a long time to run. I think Chris actually went over ensemble modeling to some degree, and it's a very involved process. But for M2M, they kind of sped it up a little bit probably, and they don't run as many for their ensemble. So this is their prediction. They put a lot of CMEs in. So pretty much anything that sun blurps out goes into the model. Anything that's on the visible disk, obviously. So that's their prediction, and that's the median for the ensemble run. So again, it's getting about early to midday on June 1st. As at least the arrival of it. And do they have an ensemble? They don't have an ensemble here, so let me close this because I like the ensemble. But so this is the median for the run. I think it's about they're on about 12 at least. And the arrival time is anywhere from early June 1st, which means if you convert to our time, it could be coming now. Probably not.
That's
Pretty
right.
wide standard deviation.
Yeah, it's pretty wide.
I want to say though,
And
the speed that's modeled that's showing to arrive is I don't know if I've seen the 1,000+ range in a model in a while. That
Yeah,
would
because
be close to accurate.
even the October 10th one wasn't that high, was it?
I don't think
I
either
don't
of
think
the
it was.
May or October events were that high.
Yeah.
October event probably wasn't as high. May event, the very last CME in that train was actually very fast.
Oh, okay.
So it was about, I think it arrived fast as well. Speeds were close to 1,000, and that was arrival speed. So speed at L1 was very fast. So it was, but that was the last CME. It sort of compressed everything and just shoved everything in our direction. That's why we got such an incredible magnetic field out of it. That was fun. But speed used in modeling is a little bit higher. And again, it's the same issue, slightly underestimated ambient speed. We're at, where are we at? Still 700?
Yeah, we're still over.
Yeah, so yeah, close to 700. Definitely over 650. So that may be a bit of a challenge. And it may introduce a little bit of an error in forecasting. So our favorite, Huxt. 500 member ensemble. So it literally is 500 different runs that are reflected here. And the change is in both space traffic and a little bit of a direction of the CME. So a spread of the CME, how wide it can be, and which way it's going, all of that kind of goes into that ensemble. And you get sort of a range of arrival time and a range of the speed. And you kind of want to see a tight ensemble, but you do see representation of uncertainty. So timing of arrival could be anywhere from midday June 1st to, well, potentially getting further into early June 2nd. And again, this models several CMEs, and some of it probably accounts for that space traffic, where a slower CME ahead of the faster one will slow it down. It gets a little bit of a drag. So basic traffic ahead of CME will slow it down. That's where we at.
That's where we're
So
at.
next one, I'm gonna pull up Swipsy, and we're gonna ask Liz to actually comment on this one, if you're up for it. So give me a sec.
I mean, I wasn't there when they actually fit, so it won't be too.
Nope. That's not the question.
Doesn't matter.
That is not the question. So let me pull it first. And I'm gonna move it over here to the shared screen. There it is. So from what I could tell, and Liz, you can definitely correct me on this one, but it looks like there are a couple of CMEs there. So there is one that definitely comes out first, that probably is more of a glancing blow. And then the second one kind of takes over and arrives around, I'm gonna say midday June.
Yeah, I think it was
1st.
around 13 or 12 UT.
Quick comment. Peak speed for solar wind according to ACE was 993 kilometers a second.
Wow.
On May the 12th of last year.
Okay, there we go. So that was the fast CME catching up on
I had to look.
Yeah, thank you. Oh, that's kind of cool. So that's where we at. So
Though actually without seeing the previous run, just can you go back to around when the first CME had popped off, but the second one, okay, yeah, can you let it go for a little bit? Yeah, because I was looking at it earlier today, and I don't think that second one really would have been Earth directed. I really think it was the big one, like merging with it at
It
that
looks like
end.
it's being pushed to the side from it.
Yeah, and also it's not, it's much slower and it's expanding much slower. So I don't think that one would have been geo effective at all, honestly. Not
Because had it as a very low probability of arrival, and which way they're gonna go, and whether or not there is actually, do they have time to expand and get in a position where they could be pushed and compressed? I don't think we know.
I don't think so either. As far as I'm not very up to date on the CME literature, but I don't actually think there's much on CME interaction from a forecasting standpoint. It's largely a lot of the forecasting, like the efforts to improve it for time arrival, are really single event focused. Um, like I know of one project that is explicitly excluding multiple events
Hmm.
passes just because it's too complicated of a problem right now. The right, the other thing that I kind of wanted to say as well is that because I was looking at it, and if you go back to 1300, like because Christian had mentioned this earlier, right? The bulk of the density is kind of, yeah, like up and then like if I'm the sun, like most of the bulk went that way. So from Earth's standpoint, it's going to be bulk is going to be coming up here-ish. So, but we're still gonna like it's still a nice, very solid direct. I mean, like that's a difference of about 40. I'm going to assume that's PFU or net density, whatever. That's a difference of 40. Like that's still an extreme jump. So even if it wasn't going particularly fast, that's still basically a nice sledgehammer coming in.
Which translates
Yeah, it's going to be a good
into,
hit.
yeah, and actually that much of a hit, and with coronal hole that is still affecting us, and
Good
still
time for the
packing some.
substorm shock conversation.
No, yes, exactly. So it's still packing some nice negative PZ, and I don't know where are we at right now with yeah, I mean it's definitely there's definitely some activity going on. So if that happens, if we still have, if we get a loaded magnetotail just before the shock arrives, even without that, that initial shock basically acts like a sledgehammer, and it's going to shake the magnetosphere into a substorm. So we could easily get some nice substorming and some nice aurora from the shock alone. The rest of it will depend once the initial shock clears and we get into that kind of mess that CME gathered on the way here, kind of compressed magnetic field and all the particles with it. Once that arrives, all the substorming will depend on whether or not we actually have decent negative BC. But initially, you can get nice substorm just out of shock.
So people freaking out when they see the shock arrive, and then you start seeing G2, G3, G4 warnings all come out and hit, doesn't necessarily mean it's going to progress longer than just that hour or two. Although it will be nice if we can be the night side of getting the shock instead of the day side for once.
Right.
Looking
Yes.
at you, universe.
Actually, I was gonna say, could I share my screen for a second?
Yes.
Because I wanted to share this. I don't know if the CCMC's CMEs scoreboard, which is not quite a scoreboard because it doesn't actually score anything. And also just quick disclaimer, it's research-based. This is not a forecast or official anything. But I just like it because it's like, here's all the M2M and Met Office, and I think also some Air Force might be on there or something. But these are all their predicted arrival times plus their uncertainty, and then the average and the median. But notice how early this is.
That's pretty early.
Yeah, we're talking that's 4 a.m. Eastern time. So like that's
Yeah.
still pretty good for the West Coast, at least.
But also that's about, 3 to 5 hours earlier than what the Met Office and SWPC are saying.
Yeah.
So I find that very interesting.
And what's interesting about the scoreboard is I'm glad they're starting to post the median, but their value is in uncertainty because their average as of at least earlier publication was performing pretty much like any other deterministic forecast, meaning it gives you a single time of arrival. So the average of the CCMC scoreboard is not better than any of the other models that are posted there. It doesn't give you better certainty. It doesn't give you better time of arrival.
No.
It just basically averages out everything and it gives you a number. That's it. It's just a number. It's not a better prediction. It's just a
Yeah.
prediction.
And for a while there, because I'm a visual person, and so I don't like the table format. So for a while, I was copying all this into Excel and making my own chart of like forest plot, and then I would put our own SWPC values on there to see how we performed and stuff. And like, yeah, it's pretty hit or miss, 50-50, whether or not the average is actually on time or not.
Yep,
Um,
pretty
and then I
much. I
lost the
mean,
Excel file. So
oh, I mean, the value is pretty much showing the uncertainty that time of arrival varies, and it could be arriving early or late. But since Huxt is not publishing there because there is really no way to put an ensemble there, except
right.
you can put the median, and then again, we know that median's gonna perform about same as any other single number forecast, so to speak. It doesn't give you the probability. So it's not posted there. And for the Met Office, again, they post the median for all the runs. They don't really post the ensemble.
Mm.
And this CCMC scoreboard could be seen as an ensemble, but since we already have Huxt, that's basically an ensemble. That, I mean, for us, that's pretty much good enough. You get a
True.
range of time of arrival, you get a range of speed, and most importantly, we don't see the KP.
Right.
What's KP?
Yes, I don't know how that KP is calculated, and I've always wondered that. I would say the two things that I liked about this, when I was working, was that it's not all just WSA and little cone models. There are other ones. I don't know how the other ones work, but I'd be very curious. But
Hmm.
also the very in-depth,
Yes.
uh,
The CME notes.
yeah,
The
I love
analysis
Yeah,
of it, yeah.
so much.
yeah, that's straight out from Donkey. So if you go to Donkey, this is exactly what CME analysis, what you're gonna see for CME analysis.
Really?
And in Donkey you see the forecast, sort of the modeling notes. So if there is uncertainty because only a few frames of LASCO and no stereo A that was available, it's going to be noted there. So
Oh, quick question.
it really helps.
Is Donkey only M2M?
Yes.
Okay. Interesting. 'Cause we don't look at Donkey at all. Or at least I didn't, and I was not trained in it. There might be one or two forecasters who look at it. For the most part, we don't use it.
I mean,
I
Donkey is
say
just
the
part, yeah, it's just a
yeah.
part of, Donkey is part of CCMC. And it's kind of events. So there are solar flares there are radiation storms that are entered there. So a
It's a
lot
lot
of
to go
events
through,
are
but
there. It's a lot to go through,
Interesting.
but for the CME, it really is the earliest run is posted by M2M always.
Interesting.
So
Okay.
they're right on top of it. I can share one more thing. I
Okay.
think it's going to be the last slide, and then we can talk
we're gonna
about
have
Aurora
pretty intense
forecast.
weather. Yeah.
Yes.
And
We're getting
so
there.
this is what
Which
happens if you enter different ambient solar wind speed and different speed for the
I
CME.
love this plot.
So do I. It's just a reminder that depending on how well you plug in even those numbers, that's how much error you can introduce. And it could be anything from 6 hours for different ambient speed to 12 hours for different CME speed. So a little bit of a discrepancy, like you have CME traveling or you're estimating the speed of CME that's coming with 1,500 kilometers per second versus 1,300 kilometers per second. That difference could be quite significant. And how good are we at measuring speed of those things?
eh.
Yeah.
We do okay. We do okay. We do okay. We do the best we can because again, it's going to be difficult to be precise. You have two satellites and you have sometimes just a couple of frames literally
Right.
but that
Yeah.
CME when it's fast, it just clears things so fast. It's really hard to measure.
One thing I will say that's a nice benchmark is, so in the forecast discussion for SWPC, they mentioned that the CME became visible in the chronograph imagery about 30 seconds after the filament eruption was seen on disk, which is pretty indicative
Ooh,
that you're going around
that's fast.
1,000. Yeah.
Yeah.
Generally, you have to wait 2 to 3 hours for it to show up in imagery.
Oh, okay.
That's
Yeah.
actually really indicative that, yeah, you have a fastball coming.
Yep. And
My
I
favorite are the ones where
actually,
Lasgo C2 only has time for like 2 frames and then it's gone.
Yeah.
yep. And I actually checked the far side. So Solar Orbiter, which can be useful for far-sighted events, it
Mhm.
was showing that the far side was quiet, so there was no contamination of that halo by far-sighted activity.
Beautiful.
Yeah, that's
So
For
always
once.
yeah.
for once,
Yeah.
exactly.
Yeah.
Because when you have simultaneous events, you have on disk, that visible disk that's facing us, and the far side that's facing the other way, and you have events happening at the same side at the same time, which is possible. You could have sympathetic flares that are doing that. Then you end up with a beautiful halo that you think is coming to us, but it's actually heading the other way. Bummer. Not good for Aurora chasers.
No. I've been burned by that before, so yeah.
Hmm.
All right. I think that about covers the events at least, but we can talk about what it means for Aurora forecast and who the G4 watch is really for.
Yeah. She laughs because yeah.
She knows.
That's a great question, and I love it. I am really uninformed when it comes to like Aurora forecasting specifically. I am much more involved for more corporate customers like the electric power grid and the aviation space. So this is fascinating.
Could that be because
So,
the forecasts there weren't made for Aurora chasers?
Mm, yeah, definitely. I mean,
so
if you want to be really technical, I mean, I'm not sure of this entirely. I haven't fully read all my sources. Yeah, but originally SWPC was the Space Environment Laboratory, which was part of not NOAA originally. It was part of something else. But before that, it was the Space Disturbance Forecast Center. And then before that, it was actually HAO,
Okay.
the High Altitude Observatory. So yeah,
Oh,
it's
I didn't know that.
so what happens when G4 watch is posted? What's sort of the standard procedure at SWPC
at
for,
SWPC.
yeah.
So assuming, yeah, done all of the forecasting, so you've got your NLO run back and you've looked at it. You are doing all the things that I said a couple of weeks ago, right? Where you're checking like how much mass do I think is coming? How fast is it going? What's the difference between the ambient before it arrives? And then you are guesstimating the sledgehammer hit. And then you're also kind of going to guesstimate where, or not so much where, like when. So like the 3-day forecast, what part of those 3 days um, is it going to be hitting? And then from there you determine, okay, what level do I think it's going to hit? Like what's the max KP that I'll see? And then from there you put out a watch if it's within that 3-day window. If it's not, then you wait until it's in the 3-day window. So like if it's going particularly slow, it might take 5 days to arrive. So you wait for a bit. Watches are out for 24 hours, just kind of by automatic default, I suppose. Um, and then nothing happens until it arrives. You are literally there sitting on shift, just staring at the solar wind display, waiting for something to happen. And maybe you will have, like the particle data at L1 up on the other side, staring at that because the protons or the electrons will tend to react to like about 15 to 30 minutes before it will hit, depending on how fast it's going. But for the most part, you're just kind of, it's like spin the tail on the donkey, except you are the donkey and you are also blindfolded. And you're just kind of waiting to see if you get hit or not. And
I like
there are
that.
plenty of times when you're sitting there and the predicted arrival time has gone, and then it'll be gone for 3 hours. You're wondering, like, did it miss? Did we all? Yeah. So it's once it actually arrives at L1, that's when everything really starts happening. Although we have started since the May storm last year, we have started alerting the electric power grid hotline as early as we can. So, for instance, Swipshe's service coordinator was doing that this morning when I was texting. So they've already given the power grid an alert to see how that's going on, but that's pretty much everything that happens beforehand. It's really kind of, okay, I've made my stab at it, and then we just wait for days.
We're in the waiting. We're in the waiting right now.
Do you guys have any statistics or like an archive of that as to, okay, this forecast was off by X amount of hours and this one was on?
Not officially.
Okay.
Does that
Well,
data exist?
Yes.
yeah.
Okay.
And yes, I mean the ish. So that's part of, so all of our forecasts and data are archived by the National Center for Environmental Information, so NCEI. And if you just Google NCEI space weather, it'll pop up. They have a new interface. It's beautiful. It's so much more user friendly than before because the previous version was an FTP, which no one knows how to use nowadays.
No, yeah,
Oh,
no. Unless you're an old school like web host
Right. So this is much
admin.
nicer. They are still in the process of uploading everything, and also there's a whole closet full of documents that need to be scanned. So, like for example, the forecast discussions only go back like I think 2 to 3 years on that site, but the weeklies go back to 1997.
oh,
Okay, that's a little
cool.
better.
And some of the other stuff like our SGARF, which stands for what is it, the Solar and Geomagnetic Activity Summary Report, some report and summary, whatever. That goes back, that's something that we send out largely for the Air Force, but that goes back to like 1960, give or
Oh,
take, I
that's
think.
wow. That's a long
I
time.
love that
That's
report.
a
That
lot more
report is
data than I
great.
thought.
Yeah.
But for like so this is the thing though, is that for like CME arrival time, you have to go digging through the forecast discussions for that. That's the only place it's really put down.
Well,
Uh,
this is, yeah, and this is where CCMC actually helpful because
Mm.
that's where research is coming from. It's based on what's been entered into CCMC scoreboard by different models and
Mm.
when actual arrival happens. So the data that a third of all forecasted arrivals are misses is coming from those studies.
Oh,
And that hasn't
good.
Ah,
changed.
Hmm.
I
So
will say, like internally to the federal government, there is an assessment of the forecast accuracy. We have to hit a certain threshold. I don't know how that is calculated or what data they're using it for. Um,
the
I
most
want,
recent forecast verification report is from 2012 to 2013. That's published on the
yeah, no,
SWIPC
that's
website.
so
internally
the
there's
Stone
a lot
Age?
more available. I've heard 2024's report, so it exists, it's just not public, I guess.
Oh,
There's something about I want to say for CME specifically, I think SWIPC is at like 60% or something like that, but I'm not
Okay.
entirely sure. Again, if you Robert Steenberg is the one who does a lot of that, so I don't know, email him if you have a specific questions.
Uh-oh, Tanya's new
Yeah.
you hear?
victim.
For new target.
New
I mean,
targets.
he was the one who trained me, so he put up with me for 6 months. So,
Well, now you can have
We
Tanya
still
and
have
Deborah.
weather.
What?
We still have weather to go over.
Oh yeah. Yeah.
right.
Yes, we do.
I do have
Oh
a
yeah,
request,
actual
MB.
terrestrial weather.
Can we make a positive weather report for once?
A positive one. I mean, the positive part of this is that it's clear.
And the caveat.
It's gonna be smoky.
What, really?
Just thought I'd prepare people. No.
Yeah. All right. So yeah, here's my the preparation for the weather forecast. Okay. So hold on, let me make sure I still have them up on the side here. I think I do. Or did I close I think did I close it all? Don't tell me I closed everything. Like a total bad person. That's okay. I can get right
I
back up.
mean, it's better than leaving everything up all the time. At least you don't
Yeah,
have 60 tabs open. I'm not that we know anyone that does that.
I don't have 50 tabs open, but well, let me bring up this because there's a couple things I've been looking at. And the one thing that I'm not sure on how, and we'll see how this plays out with the smoke thing, is like looking at the astropheric model, which is experimental, and comparing that to the particulate matter model because it's different. It's a little different, and I don't know how this like affects visibility. So I think that's what's going to be interesting to find out and see which one is probably more accurate to use. So hold on, I almost got them all up here. So thanks for bearing with me as I closed everything. And we'll do clouds. Okay, there we go. All right. Okay. All right. I got it all back up. So I'll share this now. Here we go. Let's see. You can see this, right? I have this bad habit of, sharing the wrong screens. So Windy, our favorite little weather app that we like to use because you can easily get to all the different models. Um, I just have the European model up for funsies. But let's just go to Sunday, kind of Sunday night. We'll do Sunday night. But I'll zoom out a little bit here. But look, it's actually pretty good.
That's impressive for clear
Yeah,
skies.
there's a lot of swath of clear across the Great Lakes area, Washington State. There's some clouds over like Utah, and because actually crazy me was actually gonna be pack the car up and drive from I'm in the eastern UP right now and go all the way to Utah. It's only like 24 hours or whatever. But then I saw it's be cloudy, so I'm like, you know what? We'll experiment and deal with the smoke. So we'll get to that. So that's kind of Monday night, and you see it's pretty clear. I mean, there's like some little bit of cloud, but usually the more transparent on here doesn't mean too much. So it looks pretty good overall. But let's jump over to astrophysics. So this is the bane of our existence right now, is this Canadian wildfire smoke from Saskatchewan and Manitoba, I think. And it's getting caught up in that low pressure system because you can actually watch it. It buffers a little bit, but you can actually see where the low pressure system is here. And it just kind of swings it down and around in the lower where we're at basically. So whatever, this is Sunday, yes. So this is Sunday midday, but you can watch it. So let's go 11. So it's basically all purple. Everything's gonna be purple all through here. It's like, usually purple means very, very low visibility. But the thing is, I've never tried to chase a big Aurora storm with smoke like this. I don't know if it'll get strong enough where you can actually kind of make some of the details out or not. I guess we're all gonna find out shortly here. But here's where it gets kind of interesting. So if we go to jump over to this pivotal weather, this is the particulate matter, and it doesn't look quite as terrible. Like, let me actually get to where June or where we need to be. So let's see, this is 19Z, let's see, 2. It's like somewhere around here. And see, it's like kind of thinner. Um, Especially over in some of these areas in Minnesota. I mean, I'm over here, so I'm probably screwed, but it's fine.
My area doesn't look too bad.
Yeah, but it's not quite as devastating. Maybe is the word I'm looking for. So this is where I'm gonna be curious to see what happens, and like as a learning experience, like maybe figure out which one of these is better to use in terms of dealing with the smoke issue. But the other interesting thing to note is if you notice where all the smoky areas are, and you go back to where the clouds are, anywhere where it's clear, we have smoke. Anywhere there's cloud, there's no smoke. So it's like you get to pick which one of the two evils you want.
So we found out
Yes.
what the universe's middle finger looks like.
Pretty much. So you got clouds and you got smoke. But it's unfortunate it's that time of year again. We get the I mean, I wish we had the wildflowers. Wildfire season. And it usually starts up in Canada and then the west starts to burn, which I'm a little concerned about this year because it's dry. It was drier out there this winter. So we'll see how this unfolds as the summer goes on. It's just the unfortunate thing. And as a astrophotographer, it always is sad because you get your clear skies, but then you get smoke and then you have clouds and it's just ongoing battle. And
And it's pinned right in the middle of Milky Way season. Like,
yeah, right in the middle of prime Milky Way season. So that's kind of long and short of the weather. The good news is it's relatively clear just about everywhere. The bad news is we have wildfire smoke to contend with. So I'm going to be curious to see how this pans out. And because if anything, it'll at least give us like here, maybe we'll look at this model versus this one, and maybe it's not as decimating as it seems. So there's my positive spin on it.
I can tell you that smoked aurora has an interesting look. to
Mhm.
it. It looks very diffuse. So October 10th, I was pretty much sitting under the Aurora Oval, and we had a lot of haze in the air. So in between substorms, you just don't get a whole lot of structure. It all looks very diffuse and very green, but it sort of looks diffuse and green with occasional flare-ups with kind of slight bursts of activity, the pseudo breakups. My favorite term for aurora, when it about to happen and something is going, but no, it changed its mind. No, not happening.
It just goes
Um,
back into the arc.
yeah, it just goes back into the diffuse haze. So hazy aurora, there's still a possibility of catching something, but it just doesn't have a great look. So if you want the crisp structure to the rays, if you really want to photograph
Too bad.
aurora smoke, yeah, smoke's going to interfere with it. Again, we don't know whether or not we're going to get it in the first place. So it might as well be all BZ North, and then none of us are getting Aurora, we're just getting the smoke. So honestly, I'd rather get some Aurora with the smoke than none of it, because I'm stuck with smoke anyway.
I would
Right.
agree.
Yeah, so I guess yeah, we just gotta make do with it. It's fine. I'm trying not to be like obviously it frustrates me a little, but it's I mean partially because I've been up here for uh 3 days now, and then the during that whole Hilda event that we had, there was a cloud on the northern horizon that didn't move, so I didn't even see that. So it's just kind of like, come on.
Yeah.
Oh, so anyway,
And we're sitting in a
yeah.
in a good range for visibility right now, except we still have a lot of light, and BC just moved north as usual.
Yeah,
North
as usual.
America,
Yep.
sunset, BC goes north.
Then it goes back into the diffuse featureless arc
Oh
that we
wow, it really spiked north.
Yep.
well,
Well, I'm in central Ohio, so this doesn't interest me anyway, I guess.
yes, you'll be interested in what happens tomorrow.
Hopefully.
Hopefully, exactly.
Yeah, hopefully. So anyway, I think did we cover everything?
I think, and then some. We have a special hour edition tonight.
Yeah, so that was the
So,
question. Like, yeah, so Heidi's asking, like, if it's strong
yeah.
enough, will it be seen on the horizon? And that's the $1 million question. I don't
Yeah,
think it's going to be
not
really
not sure.
Yeah, it depends how much smoke you have above
yeah.
you. It really depends where Aurora is and where the smoke is. Horizon show tends to be slightly better just because you're looking at several bands that are sort of one after another. So you're just looking at sort of slab of aurora as opposed to you looking straight up at the rays. So you can get a little bit more color because we remember if you remember how corona looks, it's several bands that are sort of above you, and they're opening above you. So if you move yourself out of that area and think about what it's going to look like from the side, it's going to be sort of curtain after curtain after curtain. So you're
Get all that
creating
light.
more color. They all line up. So you'll see more. And that's sort of one of the disadvantages of standing under the rural oval. And when it's hazy or smoky, you're just not going to see that much color. You have a better shot at something with horizon. But ultimately, it's going to depend where you at, where Aurora is, and just how much smoke or haze or sort of other thing is in the air. Fog is going to create the similar situation. It's kind of obscure some of it, and I mean, fog is essentially cloud on the ground. So if you have, I don't know, it's going to depend where you at, where Aurora's at, and just how much smoke is between you and the color.
I guess we can find out how well the Photoshop dehazing tool works.
True. Very true.
Oh God.
If there is something to dehaze.
Yeah, if there's something to dehaze. All right. Well, let's see. I think I don't think yeah, I don't
Now's a
think we
good question time if anyone's got questions.
and I don't think we had too many questions going on.
I haven't seen any. Yeah.
Just a lot of good discussion, going back and forth. So anyway, if you have any questions, fire away. If not, we'll call it a night and wish you all happy Aurora chasing, because I know we're all going to be out somewhere tomorrow.
I'll
Regardless,
probably backyard substorm hunt.
yeah, regardless of how bad the smoke is. Yeah. So there's that.
I don't know. I'm in Colorado, so it's got to be
Yeah.
really big before I see anything.
Yeah.
Go
Well,
up to
yeah.
go up to one of the mountain passes. That's my
Mm,
advice.
I hate mountain driving so much. I cannot describe to you.
Fair. I will not disagree with that. Fair. We
Well,
caught it
that
from Hoosier Pass though,
we did.
a couple months back.
But
Oh, that's
then,
right. Yeah, you were down here.
Yep.
Yeah.
but it should be strong enough. Well, should be.
That was a pretty
Hopefully,
weak
yeah.
show in comparison.
Hopefully, crossing
Yeah.
fingers.
Well,
All right.
one of the interesting things with smoke, if you want to take a picture of the sun and sunspots, you don't really need a filter.
Ah, that's a
Yeah,
good
that is
point.
true.
Now
Hmm.
it has to be dark enough, and this is important. It has to be enough that you can look at the just the surface and see it. The more you zoom in, the less reliable that becomes. You are risking it if you're using a telescope or any telephoto lenses, anything like that. Be careful. As long as the smoke is very thick and very much there, if it's going in and out,
Hmm.
don't risk your eyesight or camera gear. That's a too risky of a game. I have to say that.
Nice. I like the PSA.
Hmm.
Here, because like,
Full
yeah.
camera might still work, but yeah, my sister just sent me a picture of the sun from her apartment that looks like the Eye of Sauron. So
Ooh.
Yeah,
Yep.
that's a good way to describe it.
Mhm.
this giant red ball. I'm like, oh, that's okay.
Yep, that's what we get to deal with right now. So
Yep.
it's
So if you take a picture of that sun, say hi to 4100. Still sitting there.
still sitting there stewing in its anger.
True Eye of Sauron.
Yeah.
The eye in the eye.
All
All right.
right.
We'll let you all go. Thanks for hanging out. It's been fun. And thanks for Liz for coming on here to add some
Oh yeah, thanks for the invite. This is
commentary on
fun.
this. So we always wanted to, bring in an actual forecaster when we actually had something to talk about. Finally happened.
Hmm. Yeah, no,
So
this is a lot of fun. I enjoy this.
yeah. Yeah, we'll have to do more. Hopefully we'll have more. So thanks everybody. Happy Aurora chasing. And I will let you all go on the YouTubes.